The Higher Education Authority, the Capital Programmes Unit within that Funds Capital works within the higher education sector, co-funded by the Department of Further Higher Education, Research, Innovation and Science and the SEAI, a programme called the EEDPP, which stands for the Energy Efficiency Decarbonisation Pathfinder programme. And that is a programme that's aimed at decarbonising the sector to meet the climate action plans of 2021. So we fund those Pathfinder programmes, which allow the institutes then to meet their targets to decarbonise for 2030. We funded 15 different projects, some of which are retrofits, some of which are decarbonisation heat, and we estimate that's 2,000 tonnes of carbon per annum saving.
The University of Galway, I think, leads the way for the zero carbon future in many ways. We're very significant as a city, we're 1/4 of the population. We can make a difference not only on the university campus, but much more widely. And I think that's where we have significant impact on our suppliers, our students, our staff, and the wider community. And also then we're generating our own energy in many cases, so we're very much have sustainability at the core of what we do.
The project was set out as part of the Pathfinder is to basically install solar PV on our roof, a new air-to-water heat pump, and also the replacement of LED lighting on campus within the building, and also the installation of a new building management system. This will allow us to basically monitor all the controls, set points, and take part in data finding missions with our students as part of our research project. The retrofitting of existing buildings is a bit more complicated. You need to think more about how you're actually going to position your equipment, but also again looking at the fabric first in terms of the energy that was in the building. It was an existing gas-fired building, so we're looking to see how can we reduce our fossil fuel dependency, and that's why we went for the air-to-water heat pump. We've kept the gas as part of this retrofit project, and we're calling this a bivalent system. The bivalent system will allow us to operate the air-to-water separately or with gas, because it is a 1970s building, and whilst we are moving from a BER rating of D1 up to a B2, this will allow us to challenge the building, but also challenge the air-to-water heat pump. The main challenge is in the electrical side. Ensure the building has efficient and sufficient MIC. Your incoming power must be able to accommodate the new heat pump. Running costs will be different, so ensure that your electrical bill is in line with what's going to happen in the project going ahead.
The main construction challenges around an existing building is space. Make sure we have enough room for the large air-to-water heat pump and buffer vessels, pumps, also enough roof space for PV panels so we can fit them all in the existing building. We cantilevered the heat pump from the existing boiler room on the roof. It's been very successful, and also outdoors where it needs to be.
As part of the project, we decided to include our colleagues in engineering. So with that, we included a master's student and a researcher looking at simulation and also looking at the way we actually divide the building up and include for our BER assessment.
The Pathfinder project, it's a refurbishment project on energy efficiency on campus. So for the students, it's good because they can develop models, they can validate models with real world case study. So it's not just design or theoretical model development.
In terms of financial savings, we're estimating at the current rate about 45,000 annually on savings in electricity and also gas. We estimate to save 116 tonnes of carbon annually based on this project.
We're delighted to get this project selected as a Pathfinder. You know, it's really exciting for us. In one go, this allows us to deliver lower carbon heat into 15 buildings that are connected to our district heating scheme. And we know right now that for every unit of heat that we deliver to a building from a gas boiler and versus a heat pump, that we can save 50% carbon. So as time goes on and as the grid gets greener and as we can make our buildings more efficient, we can even improve that further. The main challenges were the electrical capacity, assessing that and making sure that that was suitable for such a large electrical consumer as a large-scale heat pump. And then the hydraulic aspect had to be looked at in terms of integrating with large-scale pipework, with large traditional heat generators, which are also in the energy centre boiler house, and just making sure that they can all operate together and we can dispatch the heat pump as a lead heat generator. So therefore it has to be reliable and it has to be maintainable. In terms of advice for other universities embarking on a path like this, get an understanding of your system and are there any temperature pinch points. For instance, heat pumps obviously operate better at a lower temperature, so it's important to understand your heating network to see, where are those areas where you need hotter temperatures. For instance, the likes of hot water. And if it's possible to quantify those, you can quantify them and identify them on your register for opportunities, and then you can find a way of re-engineering them or designing these issues out so you can operate your system at a lower temperature. We found as well that we've identified that hot water very much drives the temperature of heating systems. So where possible, if you can fit water meters to your hot water systems, it allows you to quantify them. So when the time comes to replace the system, you know that it can be sized correctly. So in terms of trying to map out your road towards decarbonisation or meeting your 2030 plan, we've found that the SEAI Gap to Target tool has been really useful. It allows you to model different energy saving scenarios and see what it looks like and what the effect is on your carbon reduction.
So here at UCC, sustainability is core to everything we do. The students go in with fantastic ideas. We have 4,000 students come in every year. We have 25,000 students overall. Lots of ideas may not work. So research with engineers, research with biologists, research with sociologists, research with behavioural scientists to see how we might change the world and make it better for sustainable and energy point of view. What we're really excited about is continuing to accelerate that programme. So by 2040, we expect to be carbon neutral again.
The Urati building was built in 1997, so it's not that particularly old. It's 25 years old, and it's a good building. It was designed for sustainability, naturally ventilated, narrow footplate. So it's kind of a building that wasn't, let's say, our worst performing building, but it was a building that we needed to do something about. So Pat Megan, our energy manager, started looking at this back in 2018, and he looked at reducing the temperature flow in the radiators to see, well, could this building be suitable for heat pump technology?
The first thing we did was replace the 6 gas boilers with 2 new condensate boilers with an air source heat pump as well. So we went from 3.5 megawatt to 1.1 megawatt of heating. We also proved that the existing radiators, they would work at a lower temperature. We started reducing the temperature of the water within the building from 80 degrees down to 70 to 60 to see how the occupants would perceive it. And to be honest, no one had any complaints. The building kept up at 21, 22 degrees during the day. And that measure proved that we could run the system at lower temperatures. We saved 23,500 kilograms of CO2 in just 1 year alone. We also saved 152,000 kilowatt hours of gas by having an air source heat pump.
There's a lot to be learned over the next couple of years in terms of monitoring that building day to day, week to week, and across the seasons to see, well, how does that building perform? We've 139 buildings, so we'd like to analyse that data and make sure that when we make our next intervention in our next building, that'll be informed by the lessons that we've learned from this particular Pathfinder. So it's not that the technologies will be the same in every building. I think you got to look at each building uniquely, see what it is will work, and make a unique approach to each building. I think that's something that we've learned from this process, that sometimes you might underestimate the potential of certain technologies, and sometimes the usage of the building can dictate how best you approach the building. I would strongly encourage other public bodies to find out what's happening in these Pathfinder projects. We're all in this boat together. We all have to learn together. It's too serious an issue to be doing in isolation. So I think this communication, the support that SEAI bring to bring everybody together is absolutely critical to the ultimate success of this programme.